This is section 254. We're going to take a look at a system of equations with three variables. So in this lesson, we're going to solve a system of equations with three variables. Now, when we solve a system of equations, as a reminder, remember we're trying to find where the graphs intersect. Now in this case, because there are three variables, it's actually three-dimensional. And that's something that we really haven't looked at yet. We haven't seen what it means to have this like three-dimensional space and a line moving through this three-dimensional space. Later in class, if we have time, it's something that we do explore. But the principle of how we solve the variables is much more important. And so that's what we're going to be focusing on today. Now, to do this, we're going to use the elimination method. It's pretty much the best, most efficient. And so with the elimination method, just to remind you, we need to eliminate a variable and we want the coefficients to be opposites. So let's look at our first example. So the goal is to look at the x's, look at the y's, look at the z's. And by looking at the x's and the y's and the z's, you should be able to say, oh, you know what? There's a variable that looks really easy to kind of eliminate with all of them. And in this case, it's going to be the y's because, this one's already opposite 1 and 2. And then all I have to do is a little thing between 1 and 3. So I want to eliminate the y's. So I'm going to pair equation 1 with equation 2. And I'm going to pair equation 1 with equation 3. So we pair one equation with the other two, the goal to eliminate the same variable. And I said I want to eliminate the y. So in eliminating the y, in that first equation, the y's are already opposites. So if I combine them together, the y's cancel out. X plus x is 2x. Z plus z is 2z. Negative 1 plus 3 is 2. Now in the other equation, if you notice, I have negative y and then positive 2y. They're not opposites. So I need to multiply the top equation by 2. And if I do that, then I get 2x minus 2y plus 2z equals negative 2. Now my y's are opposites. So now I can add my y's together. 2x plus 4x equals 6x. 2z plus z equals 3z, and that equals 6. Now notice in both of those equations, there is no y. Now we pair these remaining two equations with each other, and we want to eliminate another variable. So there's the 2x plus 2z equals 2, and the 6x plus 3z equals 6. And now I get to decide what variable do I want to eliminate. Well, it looks like with the x's, I could easily make that a negative 6. So maybe that should be my route. So I'm going to multiply the top equation by negative 3. And by doing that, now you get the negative 6x minus 6z equals negative 6. So I multiplied every value by negative 3. Now if I add those equations together, the x's will cancel out. And I'll get negative 3z equals 0. Divide both sides by negative 3. You get z equals 3. Okay, so we have one of the three variables. So now what we want to do is we want to plug it back in working backwards. And the reason why I'm saying working backwards is if I plug that z all the way into the very beginning, I still have two variables left. That doesn't help me. But if I plug in the z into one of these equations here, now what ends up happening is I only have one variable, so I can solve for it. So it doesn't matter which equation you plug it into. In this case, I'm going to plug it into the 6x plus 3z. So I plug in 0 for z, right? So I plugged in 0 for z. We're solving for x. 6x plus 0 is just 6x. Divide both sides by 6. You're getting 1. And now I can now plug these into the original because I have both a z and an x. So plugging those into the original, I just chose the bottom equation just because I felt like it. You could choose whatever equation you want, whichever one you feel is easiest. And so I plugged in my 1 for my x, right, because that's where my x went. I plugged in 0 for my z because that's where my z went. And now I just need to solve for y. So I get 4, subtract 4 on both sides, divide both sides by 2. You get y equals 2. Now we need to write it as a point because remember it intersects. So my point is going to be 1, 2, 0. Now the question is, oh, well, how do I know which order? We'll just look at the equation. X, Y, Z. So that's the order in which you're going to put your point. X, Y, Z. So reviewing this, the first thing you have to do is you have to pair one equation with the other two to eliminate a variable. And so in this instance, I paired equation 1 and 2 with 1 and 3. I was intentional about it because I wanted to eliminate the y's. So I said in both equations, I'm eliminating the y's. Then step 2, you're going to pair the two new equations and eliminate another variable. And so that's what I did here. I put those two remaining equations together and I eliminated x, and so therefore I was left with z. And then the third step, you plug back in working backwards. So I plugged z into the previous equations I just made. I got x, and then I plugged in both x and z into the original equation to get the last variable. And then don't forget to write it as a point. Let's look at another one. So for this one, pair one equation with the other two to eliminate a variable. So in this instance, it looks like it's probably a good idea to pair equation 1 and equation 2 together and equation 1 and equation 3 together. Now, what ends up happening here is, if you notice, if I add these two equations together, both the y's and the z's cancel out. Now, my original intention, I was thinking here, is maybe eliminate the z's, because this one's already going to cancel out nicely, and then I could easily make those, opposites of each other. But in this case, they canceled out. So that's okay. Sometimes that's going to happen. It's going to make your life a little bit easier, but that's okay. So I get 5x equals 15. So let's look at the other equation. They're not quite opposites yet, so I need to multiply the bottom equation by 3. Now, if I do that, you get 9x plus 9y minus 3 equals 12. Now they're opposites, so I can add them together, and they cancel out. Now, normally, you're going to pair those two new equations and eliminate another one, but one of them already has a variable by itself. So just solve it. I'm going to divide both sides by 5, and I get x equals 3. That means I just need to plug in 3 in for x into that next equation, and so I plugged it in there, and remember this is my x, and so doing the math, subtract the 30, divide by 7, you get y equals -1, and then you take that value, those two values, and you plug it into one of the originals. I chose the bottom, it doesn't matter which one you do, and then you go through and simplify it, and I got the value for z. Now again, because it was listed as x, y, z as my variables, you're going to list it as a point, x, y, and z. So in closing today's lesson, we learned about how to solve a system of 3 variables using the elimination method. This does conclude our lesson. If you have any other questions, please leave them in the comments.